Okay, so now we've already talked about in assignment 10, you learned about how to find the important points on a graph. So now we're going to find those same points, right? The y-intercepts, the x-intercepts, the vertex, but this time from an equation. So finding important points from an equation. Okay, now we've actually already done x-intercept and y-intercept, but I'm going to review it in this video just so it's all in one page of notes here for you. Okay, but I'm actually going to start with the new stuff, which is the axis of symmetry. And let's actually start with really kind of understanding, right, what we're looking for. So here is a graph of a parabola, and the axis of symmetry is this line right here. Okay, now a line that's vertical always has an equation that's like x equals a number. So like if you go to Desmos and you go to the graphing calculator and you type x equals 2, you'll have a vertical line where the x-axis says 2. So we've seen that when we looked at important points in a graph. But in an equation, and oh, sorry, I keep not leaving myself quite enough space here. In an equation, and notice I'm skipping 2 lines. Okay, here's how you find the axis of symmetry. There's a shortcut. Okay, and remember that, so the axis of symmetry is always going to be x equals a number. Always, always. Okay, because this creates a vertical line. And in Algebra 2, you get to look at parabolas that are turned sideways, but for Algebra 1, we just are looking at parabolas that are either like this or like this, and so the axis of symmetry is always a vertical up and down line, right, like this. Okay, so that x equals a number gets us that vertical line. Okay, so here is the formula for axis of symmetry. I'm going to skip a line just so it's nice and clear. It's this, x equals negative b over 2a. Negative b over 2a. Okay, so here is the example that I am going to do, and look what I'm going to do is I'm going to separate out each, right? So axis of symmetry is here. Okay, I'm going to do an example problem. So here is my example that I'm going to find all the important points. Okay, so negative b over 2a. So let's see, my b value here is 2. So negative b is negative 2 over 2a. So my a value here is 1. So that'd be 2 times 1. So this is negative 2 over 2, which is negative 1. Okay, so this is what you need to know. This is the formula for the axis of symmetry. And here is my example, and in my example problem, my axis of symmetry is at x equals negative 1, which is a vertical line, right? Like if I had a graph like this, here's my x-axis and my y-axis. My axis of symmetry would be right here at x equals negative 1. Okay, let's talk next about how to find the vertex of this parabola. Now here's the thing about the vertex. The vertex is on the axis of symmetry, right? Like in this picture, here's the vertex right here. It lies on that line. Here's the axis of symmetry, here's the vertex. So what I'm going to do is I'm going to take, right, I just found this x value, and what I need for the vertex is a point. I need an x and a y value, so I'm going to plug in the axis of symmetry, x value, right, that I just found, is right here, in for x in the equation. Because that's going to tell me, oh, well, when x is negative 1, right, when we're at this point on the graph, here's what y is. So if you take a look at this equation, right, here is my example equation. I'm going to plug in negative 1 for x. Okay. So negative 1 squared, negative 1 times negative 1 is 1. 2 times negative 1 is negative 2. So I'm actually going to do this. Okay, so now you can put this all in your calculator at once if you want. 1 minus 2 minus 8, or you can do 1 minus 2, that's negative 1, minus 8, it's negative 9. So my vertex is, my x value was negative 1, and my y value is negative 9. So this would be my vertex, right? And if you think about where it is on the graph, it's going to be right here on the axis of symmetry. Okay, and then when I go ahead and find the x and y intercepts, I'll be able to draw like a little bit more of a complete graph. Now you might be wondering, is this vertex a maximum or a minimum, right? Now like here, right, this vertex is a maximum because it's on top of the graph, whereas this vertex is a minimum because it's on the bottom of the graph. So how do I know just by looking at an equation whether a vertex is a maximum or a minimum? Okay, I'm going to tell you how. In an equation where the a value, remember it's this value right here, the a value, okay, if a is positive, that means the parabola will be turned this way, okay, like a U, and then therefore the vertex will be a minimum because it'll be on the bottom of the graph. Okay. Now on the other hand, if a is negative, that results in a parabola that's flipped this way, and then that way the vertex will be at the top of the graph, and it'll be a maximum. So here you don't have to do any math, you just take a look and you say, oh, that a is positive, so therefore it's a minimum. So like in this case, it would be a minimum for this example. Or if this was like a -2, then it would be a maximum because the graph would be turned this way and the vertex would be on top of the graph.